we are going to break down the syntax and internal logic of Java, the language that literally runs the modern world. The core philosophy of Java is simple: write once, run anywhere. By compiling code into a universal format that any system can understand, developers can deploy the same program across billions of different devices globally without rewriting the source code. This diagram illustrates the breadth of that ecosystem. Java provides the underlying infrastructure for everything from Android mobile apps to the enterprise systems processing global finance. It is used for big data frameworks like Hadoop and Spark, and serves as a primary language for cloud services on AWS and Azure. Because of this massive footprint, the global market for developers who can maintain these systems is projected to grow by over 30% in the coming years. This chart maps the current earning potential for these roles. In India, a mid-level Java developer averages around 8.8 lakh rupees a year. For senior roles at top product companies, that figure often exceeds 20 lakh. Reaching those milestones requires a deep understanding of foundational coding. Mastering these mechanics is the first step towards securing a role in the global tech economy. Before writing a single line of code, you have to configure a functional programming environment on your machine. As shown in this setup guide, there are two primary requirements. First, you install the Java Development Kit, or JDK. This is the engine that compiles and runs your code. Second, you select an integrated development environment, like IntelliJ or Eclipse, to act as your workspace for writing and debugging. Once the environment is ready, we test the configuration with a classic starting point. Executing system.out.println hello world confirms that the JDK and IDE are communicating correctly. With the environment properly configured, we have the foundation necessary to begin layering in more complex programming concepts. All software relies on the ability to store and organize information. In Java, we use variables and data types to define how that information is held in memory. This breakdown shows the two main data categories. Primitive types store simple values directly. Non-primitive types, like arrays, hold complex data. To manipulate this, we use arithmetic operators for calculations and relational or logical operators to evaluate conditions. Data storage is only half the battle. To make a program functional, we need logic dictating how the code reacts to different inputs. This diagram illustrates primary conditional tools. If-else and switch statements allow the program to make autonomous decisions based on changing criteria. To handle repetitive tasks efficiently, for and while loops iterate through data, removing the need to rewrite instructions. Applying this logic to structured data allows commands to function as an automated system. As programs become more complex, we move away from simple scripts and toward object-oriented programming, or OOP, a framework designed to model real-world problems. This module shows OOP's core relationship. Classes are blueprints, while objects are instances that perform work. We increase efficiency through inheritance and polymorphism. For security and simplicity, encapsulation hides internal data, while abstraction presents a simple interface, masking underlying complexity. Even with a strong architecture, a runtime error can occur. Without a way to manage these events, a single glitch stops the entire application. Exception handling provides a way to catch these errors before they cause a crash. Using try-catch blocks, developers manage unexpected failures and keep the rest of the program stable. Developing these 4 OOP pillars and a robust approach to error handling provides the structural discipline required for high-level professional development. We've traced the progression of a Java developer, from configuring a JDK to organizing code with advanced object-oriented design. This core Java knowledge provides the essential foundation for the more specialized tools used in enterprise banking and global cloud infrastructure. The next step is to test these skills on your own. Take these foundational mechanics and apply them to independent, real-world projects to start building your portfolio. If this guide helped you visualize your path in tech, like this video and subscribe to continue your journey into professional software development. I'll see you in the next one.